Good afternoon, ladies and gentlemen. Thank you for coming and thank you for having me on the great DevFest. Today I'm going to talk to you about our Wasty project when we have used a bunch of Google technologies. First, I would like to introduce myself. As I said, I am Ivan Kutil and I am co-founder and Google architect of AppSatori. AppSatori, we are based in Czech Republic and we are Google Cloud partner for G Suite and Chrome devices. We are offering professional services in deployment, integration, development, and we are also product focused. About 2 years ago, we have developed the product named Signature Satori, which is a tool for create a Gmail signature in your domain centrally. Since 2013, I'm the part of the program named Google Developer Expert. This program contains almost 300 developers, programmers, UX designers, and hackers who speak, promote, and write articles about Google technologies. I have deep experience with G Suite platform, especially with Google Apps Script, almost eight years. And I have also experience with deployment and training the users to use G Suite platform. My objective for today is show you like the architecture and big picture of all Google technologies which we have used. First, my presentation will be divided into two main parts. First, I would like to introduce you shortly into the business, and then I will show you how we solve it by Google technologies. So let's go. First, business summary. Most of you are probably familiar with clothes recycling. So there are many special containers in the street, and people put old clothes into these containers. And there are several companies who are focused to grab these old clothes and doing some recycled stuff. This company has many drivers, and these drivers routing around the city and grabbing these clothes to this car, and they moved these clothes to the big container, and then the clothes are sorted and divided into the several parts. In Czech Republic, we have partnered with a company named Dimatex, and they had almost 2,500 containers located in the street. And their drivers used to do very boring stuff. So driver came to the container, grabbed the old clothes, and checked the condition of the container. Like, okay, this container must be clean, and there is about 80% of full of these containers. These drivers had to write the notes to the paper, and this boring stuff is happening about up to 40 times each day and every week and every year. And it didn't stop because these drivers have to rewrite these numbers from the paper to the Google spreadsheet. So they have to spend almost 2 hours every day to rewrite numbers from the paper to the some online system. And why? Because this company created a Google spreadsheet for every region for creating like the simple statistic visualization and some simple reports for the owner of company. And there are some obstacles, like in some region, there are 2 drivers, for example, collecting the same container. So we have to solve how to do like the synchronization of the state, how this big container is full. So we have to solve it by some technology. And now it's about the technology summary, which Google technology we have used for solving this problem. We have divided our architecture into the several modules. Every module is one box on the slide. First is data collection. We didn't want to buy special and expensive hardware or create a native mobile application for Android or iOS. In the same time, I have read article by Alex Russell, who works in Google, and he wrote about the progressive web app, and I said, wow, it looks like interesting. I think it's okay.
No, just close it. Just close it.
Yeah. No, yeah, it's work. Yeah, cool. Thank you. And what is the progressive web app? Here is some definition. Progressive web app use the modern web capabilities to deliver app-like user experience. That means that you are writing and you are using the web technology to write, and the results looks like and behave like native mobile application. There are several, not requirements, but recommendation how your progressive web app should behave. In my point of view, the most important one is installable, that you can install your web application among your native application in your mobile. Your application is safe, so your application must be hosted with SSL certificate, and connectivity independent. Your progressive web app should work even without the internet, so in offline mode. In our case, we used progressive web app. Here is the small demo, and we used about 90% vanilla plain and JavaScript. We didn't use any fancy and cool JavaScript framework. And for small part, we used jQuery because we doing cross-site request to another server, so we used JSON-P. So for this reason, we have used jQuery, but I would like to rewrite this small piece of code to the native JavaScript fetch, because it's since ECMAScript 2016. For local database, we have used simple local storage. So we didn't use any cool and database in the browser, because we are storing just information which user is logged, and we are using like this container is 80% full and it's a few kilobytes. So for this reason, we are using simple local storage. Our application is fully material designed. For that, we used Google CSS library, getmdl.io. It's very easy to use in your application, and our application is hosted fully on Firebase hosting with SSL certificate. This hosting is complete free. If you want to create and use the progressive web app, you have to start with the manifest. Manifest is a simple JSON file. It looks like this, and your manifest define your application. So it defined the name, description, several icons in several sizes, the theme color of the browser, orientation, and display. So it's very simple. It's not rocket science. For offline support, we have to use the service worker. Service worker is something like the proxy between your application, like progressive web app, and between the server. So first, in your main JavaScript file, you set up and install your service worker. First, you check that the service worker is available in this browser, and if it's available, you registered this service worker. Then, for the first time, when your application is loaded, the event install is fired, and you have the cache version name, like, for example, my application, and you set up by array which assets or files do you want to cache. In this example, I cached some image, JavaScript file, CSS file, and some fonts. And for the first time, all the data from the server are loaded to the local cache of the browser. And activate is the next event. Activate is loaded and fired every time when you open again your application, and only check if the version of cache is incremented, and if is it incremented, it loads new data to the cache. And that's simple. Now you listen the fetch event, and when you are trying to get data from the server, like if you are trying to get, for example, the image, first this snippet just check if this file is available in the cache, and if it is available in the cache, it loaded from the cache, but not for the server. So it speed up your application, and it works even in offline mode. For offline and online states, like if you want to inform your user that now you are offline and now you are online, you can listen to simple events. First is online and offline, and then you can change like the user interface a little bit, like as we did in our application. Now you are offline. Now you are online. As I said, we didn't buy expensive hardware, but we bought very simple, probably the cheapest Android devices with NFC supported, and we pre-install the Chrome devices. Because we bought the same Android devices, it's very easy to debug all this stuff because we know which devices are used. We also bought NFC chip. For each container, we bought one NFC chip. The price of NFC chip is about €1, and we loaded the URL of our progressive web app application, which contains like the progressive web app, like the domain, which is hosted on Firebase, and the second part is the container ID, and we put into the container. And here is a simple use case. Driver just come to the container, open the container, grab the old clothes, and touch with their smartphone. With NFC chip, our application is loaded, and because everything is cached in the browser, so it works even offline, and the user or driver just check, okay, this container is about 80% full, and this container must be, for example, cleaned. We didn't stop, and we used the passive chip, but we would like to improve our system. So we using the active sensor. We partner with company named Sensoneo. It's hardware company from Slovakia, and they developed the sensor based on ultrasonic. So they are sending every 8 hours the measure of the container, and they are using the Sigfox network, and we are getting the temperature and the distance. Sigfox is the operator of Internet of Things network. So for us, it's very easy to use because Sensoneo is directly connected to the Sigfox. Sigfox sends data to the cloud, and when the measurement for the hardware is sent, we are getting the callback to our server. So here is the screenshot from the Sigfox backend. It's very easy. You just set up your callback URL. In our case, we used Google App Script, and we are getting data every time when the measurement is happened. So this was first about the data collection. Now about something what we are calling API gateway. For this one, we used Google App Script. Here is the definition by Google. So Google App Script is serverless, because serverless is now very trendy and fancy topic. Serverless, so you don't need to manage the server. It's based on the JavaScript, so you don't need to learn something new like the new language or new script formatting code. And it's for G Suite, but not only. And it's for automation, so you can automate your business processes. You can extension of your Google spreadsheet documents, slides, forms, or you can integration among your Google APIs. So in my point, Google App Script is very useful because instead of calling Google REST API, you are just calling the method in object. Like in this example, when you want to send email by Gmail, you are calling just Gmail app.send email with 3 parameters. First is recipient, second one is the subject of the email, and the last one is the body of the email. And when you run this script, one line of code, you are sending the email. All the development of Google Apps Script is happened in the browser, also all deployment, and I love it, and also it's very useful for the beginners because you don't need to set up the environment and ID and all the dependencies. You just open the browser and start coding. And Google Apps Script also handle all the authorization and authentication stuff, like dancing with access and refresh token is very boring, and Google Apps Script is doing on behalf of you. Here is the simple code snippet. Instead of these images, you can imagine Google service, like first I will get the documents from my Google Drive, get the content and iterate over the document, translate from one language to another one, and iterate over the context and send email to each my context. So it's very easy to learn and easy to use. Creating new Google Apps Script application is as simple as creating new Google document. In your Google Drive or G Suite or in Gmail account, you just click in the new, more, and Google Apps Script, and new IDE for writing the code is opened. The IDE also has code suggestion, so you don't need to remember all the stuff. You just type Gmail, and this IDE suggests you the right name of functions, and you can integrate to any G Suite services or to any Google API or to any public API. So you can very easily to create like the Google Maps, integrate to the Google Analytics, G+, BigQuery, and or Google Cloud Platform. What is very interesting that with the Google Apps Script, you can also publish your script as the public with public URL. When you are writing function do get or function do post, these two functions handle the specific HTTP verb. So in the case of do get, when you calling the unique URL which Google generates for you by get, this function is run, and when you calling the same URL with the post, another function is run. And you can define what would you want to return, simple HTML, JSON, XML, TXT, or wage card, and so on. In our case, we created like the simple API for the Google Spreadsheet. So we create the function do get, and when you are sending the data with 2 parameters, action like the save, and data is simple like JSON format because it's easy to manage it. We can check, okay, this is the parameter action, then open the Google Spreadsheet with specific ID, open the specific sheet name, and add new row to the Google Spreadsheet and stringify the results and return as a JSON. So it's very easy. In several lines of code, you can create API for your Google Spreadsheet. As we extend our system for next container, like also for paper and plastic and glass, we have to decide what is the type of the container or the color. So for this purpose, we create the simple Google Apps Script application with public HTML, and with the JavaScript we can touch to camera on the phone, and user just took the picture of the container. GPS coordinates is loaded from the smartphone, and we send this image to our Google Apps Script, and from the Google Apps Script we are connected to the Google Cloud Vision API, what is machine learning as a service, and we are getting the label annotation. So we can recognize that this is on the image is recycling, yellow, waste, automotive. So we can add like the more metadata to the container. Saving data, For data, we have used simple Google Spreadsheet as a database. So we have one Google Spreadsheet, and for each container, we have one row. And it's very easy for us, and it's very easy for the partner or our customers, because they know how to use and control Google Spreadsheet, so they can define very easily new container, delete it, or change the state of the container. For the raw data, we have to use Google Fusion Tables. I'm saying that Google Fusion Tables is like something like Google Spreadsheet on steroids. You can use Google Fusion Tables with API, and you can ask SQL queries through this API. So we are saving raw data about the collection into the Google Spreadsheet. As you see, that every row is one collection with the date, GPS location, container ID, user ID, amount, spreadsheet ID, partner, region, and so on. All data about the containers, like the photos, we are saving in Google Drive. Again, it's very easy to creating new file and upload it, because we are using through the native Google user interface. And it was about the saving data. For the real-time feedback, my favorite part, we have to use the Google Firebase. So Gerard said almost everything about Firebase, so just a quick recapitulation. Firebase is like something like a big JSON, and it's doing a synchronization between the connected user behalf of you. So we are using the real-time database, and we are using the hosting. So our application is hosted on custom domain with SSL certificate. Our database is structured into the 3 levels. On the first level, we have one node for each region. In the second level, we have something like the state, because container can be in different states, like active or archive. So this is the red color. And on the last third level, there is the container about the capacity, when it was created, about how this container is filled, and so on. For creating something like the manager dashboards, we have to use the Google Sites. Google Sites is a content management system for creating public or private project site in your domain. And it's again very easy to use. And for category or every item in the menu, we have to use active Google Apps Script as a HTML service. So first, for example, we created a simple container management. Again, we have to use material design. On the left, you will see like you can filter with the region, city, and so on. On the right, you will see the metadata about the container, like the photo, which is loaded from the Google Drive, some simple statistics from Fusion Tables, some basic information about the city. In the middle, there is the Google Maps with color if this container is okay or needs to, for example, clean or move. For route planning, we have used another Google's API. So in our system, we want to get ability for the user to select several containers and plan the best route between these containers. So for this, we have to use Google Maps Direction API. Google Maps Direction API is well known that you can set up 2 points, start point and end point, and Google will find you the best route between these 2 points. But not a lot of people know that if you add the parameter optimize true and add more containers unsorted up to 21, Google will find you the best route among these containers. So you can solve very simple trolling salesman problem with just this Google's API. Another Google technology which we have used is Google Cloud Function, because sometimes someone took image of the container but in wrong orientation. So for that we have to create like some automation tool how to rotate these images. For that we are thinking about the microservices architecture, and because it's simple function, just only rotate the image. So for that reason we have to use Google Cloud Function, which allows you to scale only one feature on or function. Google Cloud Function is a Node.js environment, so this means you can use any npm package. In our case we used npm package GIMP, and there are several triggers. First, a simple HTTP trigger. When you touch to the URL, you will get the result. Another triggers is using Google pops up, which is the Google messaging system, or when you fired event in Google Cloud Storage. In our case, we used a simple HTTP request, and from our Google App script, we just sent our image as a base 64 to this Google Cloud Function API, and we will get the result of rotated images. Again, it's simple, several line of code. For visualization, we have used Google Charts SDK. It's again very simple, because first you have to define something which is named data structure data table. It contains several columns and several rows. It's something like 2D array. And when you set up the Google data table, you can connect Google data table with any visualization. In our case, we connect our data table with the bar chart, and Google will generate the simple chart for us. So it's again very easy to use. For visualization and geocoding on the map, we used Google Maps JavaScript SDK. It's again simple, because when you do want to compare two time series or 2 months, like for example January and February, and compare if there is more kilograms or less. So for this reason we create like the map, and we compare two numbers and put the custom icon. Okay, it's a lower number or higher number. And we also used a real-time dashboard again on the Google sites, and it's connected to the Firebase, so the users who control the system or all the drivers see, okay, this container is almost full, I have to solve it right now by phone. And that brings me to the end. So now it's time for a quick recapitulation. Our architecture. So first we used NFC chip, simple NFC chip, and we used progressive WebApp. So we didn't write any code of native on the web. So we bought 10 cheap Android devices, and everything is cached in the local cache, and by service worker we can also assets available in offline mode. For the API, we didn't use something like App Engine. We used simple Google App Script, because Google App Script allows you create like the public URL, and you can handle the data. Or data is saving to the specific Google spreadsheet, because there are several Google spreadsheets for each region, and these Google spreadsheets are saved in the Google Drive. We have also Google Fusion Tables for saving all raw data, for creating the statistics, and using Google Fusion Tables complete for free. And because Google Fusion Tables allows you to access to your data through the API, and you can query SQL query, so it's very easy to use for create some grouping and select and where and so on. And for the real time, like the synchronization between in some region, then two drivers put data into the same container, we are using Firebase, and we are using Firebase for the free hosting on our custom domain. And for the manager dashboard, we have used Google Sites with several models. First is Google Charts API for creating custom Google chart, Maps JavaScript API for showing data on the map, and Maps direction API for planning the best route among some point on the map. So that was all. So thank you for your attention, and now it's time for your question, or I will be available nearby. So thank you.